joining the session. Can you guys all hear me? If you cannot hear me, you can use the headsets which they have on the back. I'm Vivek Chauhan. I'll be presenting this session with my friend and colleague Jet. We also have a special guest, Nico from Harvey, who will be joining the call. Today, we are going to talk about how you can save a ton of money and build application-specific, production-grade, inference-optimized AI using open-source models, leveraging Fireworks, and then how you can serve those models for inference on Foundry. Cool? Okay, let's get started. There are three fundamental truths we believe in the AI's landscape right now. Number one, for all practical purposes, for most enterprise use cases, the gap between open-weight models and frontier closed models has collapsed. What it means is that a lot of the companies can switch to an open-weight model if they want to while keeping the same quality bar and save a ton of money. As compared to pointing, let's say, Claude Opus 4.7 for an email summarization task, you can use a smaller model and open-weight model and get to the same quality and save money. The second thing, the true differentiation only comes from actually embedding your own data mode into the AI. If you are using the same closed-weight model which every one of your competitors is using, there is no differentiation. If you want to truly differentiate your own AI stack, leveraging fine-tuning is actually very key. And third, and the most important thing, the most leading companies in this space, which we see on our platform, are actually going beyond just inference or inference optimization or fine-tuning. They are continuously improving their AI stack, and they have found a flywheel on our platform through which they can actually have a very differentiated mode. And we'll talk about how leveraging Fireworks, you can get the same mode on your platform. And we have the platform on Fireworks AI side where we provide world-class inference and training, so we'll cover that also. Okay, a little bit about Fireworks AI. We process more than 30 trillion tokens per day. It's actually right behind frontier closed-weight labs like Claude and Anthropic and OpenAI. We serve more than 10,000 enterprise customers globally who leverage our platform to build production-grade applications using open-weight models. You have some names on the screen. Cursor actually leverage our RL rollout capabilities to build Composer 2, Composer 2.5 models. We have customers like Vercel, Genspark, Uber, DoorDash, a long list of customers who lean on us for better quality through fine-tuning and training, better performance. It could be speed, it could be throughput, time to first token, whatever is your application-specific need, we're able to take care of that using our platform. How do we do that? We have our own inference engine, our own inference stack. If you think about it, LLM inference actually is a very, very difficult and very brutal combinatorial problem. Across optimizations on speculative decoding or quantization modes, various different queues you have access to, different parallelization strategies. There's more than 85,000 permutations, 84,000 permutations for one model, which you want to serve. For most companies, it does not make sense to actually deal with this complexity in-house. They would rather focus on their users, their application, and lean on our platform because we keep up with the space. The space is moving too fast. We deal with everything in terms of the CUDA kernels, in terms of quantization, spec decoding, adaptive caching, every new fancy AI optimization trick which comes out, we embed that in our stack. You don't have to worry about it. You can focus on your application, and we can take care of your specific needs. I want my time to first token to be less than 500 milliseconds. I want my end-to-end latency to be less than 2 seconds. I want my throughput to be such. We can take care of that using our inference engine. And all of these inference engine capabilities are now available on Foundry, and we'll talk about that. We'll do a live demo of that. This slide actually is my favorite slide. We want all companies to actually own their AI stack. It's paramount that companies do that. And we want to meet customers where they are in their journey. Different companies are actually in different stages of their AI journey. In fact, within a company also, different teams are in different stages of their AI journey. We want to find a way to meet them where they are. We have a training agent, which is more targeted towards product managers and app builders. The training agent basically can take your data and your business use case, and it can give you a fine-tuned model. We'll give you a live demo. We'll give you a demo of the agent right now. We have a managed training platform, which is more targeted towards ML engineers. If you already know what training method you want to use. You already have a data set which you want to use. You can literally just port the data set and kick off a training job on the platform. You do not have to worry about any of the backend infrastructure orchestration. We take care of that. If you are an advanced ML team, if you are researchers, you actually would love our training API product. With the training API product, we expose the raw primitives of the platform. Custom loss functions, reward functions, advanced algo suite, if you want access to highest context window, full parameter fine-tuning. We provide that in our training API, and we'll talk about that. Basically, we have a surface from high to very low controls, depending on what you want, and you can actually meet your key needs in one platform. And no matter what surface you use, you can one-click deploy in the platform, which is very, very important for speed of iteration. As compared to training somewhere and doing inference somewhere else, downloading, reformatting, you don't have to deal with any of that. One-click deploy, run your evals, ship it to production. And this is the flywheel I was talking about. We are already seeing leading companies in the space find this flywheel on our platform. And they're actually spinning faster and faster. They are training models on the platform, they're deploying it on the platform, they're monitoring it, they're getting the traces out of it, they're retraining it. And they're able to do that on our platform because we take care of the complex part. We take care of the GPU orchestrations. You don't need to scavenge for GPUs, you don't need to worry about elasticity, you don't need to worry about bad nodes or CSP issues. That's our headache. We take care of just the core part of the flywheel itself in terms of like porting the weights over, hot loading, checkpointing. That's not your pain point. As compared to doing this DIY in-house, which might take you many, many weeks, you can probably get 10 iterations done in Fireworks. The third thing is we guarantee numerical fidelity for you. It's actually a very big thing. When you're training a large model, when you're training an NMOE model, which is using floating point precision, the numerics can drift a lot. What you train on might not be what you serve on. And we guarantee numerics where you don't have to worry about that. You can be assured that what I trained, the eval results I got, is matching the production platform performance for my end users. And again, no vendors for all. Everything is on one platform, training and inference, one-click deploy, and you can focus on an application and leave the infrastructure to us. Okay, enough with the slides. Let's do some live demo. Actually, recorded demo. So I'm going to start with a demo of the training agent. The idea is very simple. Actually, let me ask a question first. How many of you love writing evals and reformatting data? No one? Okay, so the agent is for you. The idea behind the agent is very simple. You speak in plain English. This is my data set. This is my business goal. And you help me fine-tune a model. The agent can reformat the data. The agent can write evals for you. The agent can help you find a model which might be good for your use case. The agent can do hyperparameter search for you. So usually when you are doing a fine-tuning of the model, there are so many knobs you can tweak to get to the output you're looking for. And it's actually very painful to go through all the permutations manually, one by one. You don't have to do that. We have an agent which can take your business use case, deal with model selection, eval writing, data formatting, and it can give you a plan. And the plan will outline what the agent is proposing. It can also tell you upfront what it will cost you to do this training iteration. Once you're happy with the plan at a high level, you can just say, okay, you know what, approved, go ahead. Then the agent will take your data set, make a small cut of that data set, and do the hyperparameter grid search on that data set to narrow down the sample space. And once it has narrowed down the sample space, it will ask you again, okay, you know what, I tried like these 10 different iterations. These are the two which are the most promising. This is the reason why it's more promising along with the eval results. Do you want me to do a full run, the full data set run on the platform? Once you say yes, the agent will take your full data set and it will actually do the whole training run on your full data set. It will give you a very comprehensive, like step-by-step view of what's happening under the hood, and it will give you a final report in the end. Everything which I'm showing here on the screen is actually available in a headless fashion. So we have a skill file. If you want to train a model directly from your own coding agent, from your own harness, GitHub Copilot, Claude, Cursor, you name it, you can just drop the skill file, add your API keys, and you're good to go. It also gives you suggestions on what else you could do if you want to do more iterations on top of it. The agent can take care of your supervised fine-tuning needs. It can take care of preference optimization needs. It can help you make a model for classification tasks. All of that is packaged already. Okay, so agent is for people who do not want to like deal with the ML part of it. We also have a very simple clickable workflow. If you want to just train a model and you have a data set already, and if you know which method you want to use, what hyperparams you want to use. What I'm showing on the screen is our managed training product. You can come into the platform and you can choose supervised fine-tuning, reinforcement fine-tuning, preference optimization, and just select the workflow you want to go with. You can choose the model. We are usually day zero provider for open weight models for inference. That also means we are one of the fastest providers for supporting fine-tuning on open weight models. You can come in here, select the model you want. Once you have selected the model, you can upload the data set directly. We also provide secure training, so you can actually stream data BYOB directly from your own cloud. And we expose raw parameters where you can choose the epochs, the learning rate, the batch size. A lot of like smart defaults are available out of the box to you, and you can basically kick off a training job. If you want to do reinforcement fine-tuning, there's one additional step. Basically, you have to upload your grader or connect your grader using your GitHub repo so that the reinforcement tuning job can use that grader to actually give rewards to the agent, to the model. And again, we expose features where you can change your different knobs, top K, top P, etc., along with batch size, learning rate. We also support weights and biases. So if you want more detailed telemetry, you can just plug in your API key and get weights and biases, so you can actually monitor what's happening under the hood. If you want to do preference optimization, that's also supported. Similar setup, upload the data, choose the configs you want to run as many times as you want to run. All your trained models show up on the platform, and while the training job is going on, you can actually monitor the results live on the platform. It will show you the loss function or the reward function in real time, so you can see if it's behaving as it's supposed to behave or not. You can pause something if it's not behaving, redo the reward functions or whatever eval you have picked up for the job. The best part of this whole thing is that you can one-click deploy. You do not have to worry about downloading the weights, reformatting it, uploading it somewhere, worry about numerics, and just waste time on it. Just one-click deploy on the platform. And also, we provide compound training. So you can take a supervised fine-tuned model and then do DPO on top of it. Then take a DPO model, do reinforcement learning on top of it. And you can do as many iterations or passes as you want. That's the flywheel I was talking about of continuous iteration and continuous training. Okay, what happens once you train the model? This is the part where we talk about inference and doing dedicated deployment. So we support on-demand deployment of these fine-tuned models. Again, we support the largest array of open weight models. You can do inference on just like base model on the platform if you want to. We also support inference on the fine-tuned model, which I was talking about. So basically, just come and select the model. One thing which is interesting here, remember I was talking about how using our Fire Optimizer capabilities, we're able to give you custom shapes of the model specific to your own traffic. You're seeing an example here. The same model on the same number of GPUs can give you very different performance depending on how you have orchestrated and packaged the whole GPU stack, from CUDA kernels to spec decoding to everything around it. You're seeing an example here. The same model can be served in a minimal shape way or a full precision shape way, can be served for optimized for speed, optimized for throughput. The screen is showing you selecting a custom tuned model, and you can choose the shape you want depending on your application's need, and basically one-click deploy that shape on the model. We also support auto-scaling, so you don't have to worry about peaks and troughs of your traffic. We already scale up and scale down as your traffic shifts. And yeah, that's how the deployment works. I also talked about the training API a couple of slides before. What is the training API? If you want raw power of the platform exposed to you because you're an advanced ML user, this is what you need. We take care of everything behind the scene in terms of infra, but still give you all the knobs exposed to you. You can write your own custom loss functions. You can go with the latest and greatest algorithms out there. Everybody's talking about on-policy distillation right now. CISPO, all these things are available. And then you have full parameter fine-tuning. We have a cookbook, which has a bunch of recipes in a GitHub repo, which is publicly available. You don't have to write something from scratch if you don't want to. Just pick a recipe, change the knobs, The beauty about this particular product is that you can train the model from within your harness. And that's actually very important. AI needs to learn how to do the job better, but it needs to learn how to do the job better from within your environment, from within your harness, knowing which tools it has access to and how to orchestrate these tools. With the training API, we are giving those capabilities to you. We'll also talk a little bit about harness and AI model coming together for fine-tuning as we go to the later half of the session. And there's a bunch of examples which you can use to get started. You don't have to worry about like writing something from scratch. You can train a 1 trillion parameter model from your laptop. And we take care of all the infra. Cool. OK. So we also want to talk about an exciting announcement we had yesterday on Satya's keynote about Fireworks being available on Foundry. Everything which I showed you in terms of inference deployment is available on Foundry. The training side is not. You can train a model on Fireworks, and you can download and move it to a custom model deployment on Foundry. So you don't have to worry about that. And we have an announcement video.
And now, which is the exciting thing that we're here together to announce, is the general availability of Fireworks in Microsoft Foundry, and how customers can not only take all of the greatness that Fireworks has to offer, but also all of the greatness that Foundry has to offer in a simplified way, one endpoint, one contract, and one journey, one platform. So I'm super excited. Thank you, Lean. It's been an amazing partnership with your team.
Thank you, Vivek, for introducing Fireworks. Now, what you're all here for today, in terms of how Fireworks actually fits on Foundry and how to go from that model catalog on Azure Foundry all the way into production. It's actually quite straightforward. And before we even get into that and a demo, let's talk about why customers choose Fireworks on Foundry specifically. For mainly 4 key reasons. One, because of performance. So my colleague Vivek actually introduced our inference engine that helps you do optimization from a CUDA kernel level up. And so when customers come to us, we can actually optimize for their specific use case and give the most out of the GPU when the model sits on top of the GPU for their inferencing needs and use case. The second reason being the model advantage. Most of the models that are released on Fireworks, we release it on day 0. So when DeepSeek V4 came out or the 𝗬𝗍 2.6 came out, we tried our best to release all these state-of-the-art open source models on day 0, so you can plug it into your agents as soon as they come out. The third reason being more of control and extensibility itself. So a lot of the custom models can now be deployed on Foundry through the integration of Fireworks and Azure Foundry catalog itself. The last being economics. This is what most customers really care about. When you start scaling these closed source models specifically in your applications, they get really expensive really quickly. So what customers are looking for is a cheaper alternative, at the same time meeting the quality that these closed source models give. And that's what the models on Fireworks actually provide. And integrated with Azure Foundry, it's even more easier for you to use up these Azure credits that you have on Foundry itself. So there are 3 main integration modes that customers use when integrating Fireworks with Foundry. The first being serverless. These are models that are deployed on Foundry, and you don't really have to create a deployment per se. It's already created. It's a shared deployment among multiple users. It is per token basis. You'll be charged per token when you use this particular model on Foundry. So we have a lot of state-of-the-art OSS models available today through Foundry in this particular mode, that is the serverless or pay-as-you-go mode. We have GLM 5.1, 𝗬𝗍 2.6, GPT 120B, and we are releasing models as they come as well. The second mode being the PTU or provisional throughput mode. This is when you already have a production workload in mind, and you want to reserve some GPUs and deploy a model for your specific use case. This is PTU gated, and it works really, really well for production workloads specifically. And then the last one being bring your own weights. A lot of the customers, when they come to us, and when they're especially competing with closed source models, they've trained open source models to compete with them in terms of quality. And when they have their own models that they have trained and the custom weights, they want to deploy it on Foundry. So like Vivek mentioned, you can train these models on Fireworks and then download the model weights, upload it to Azure, and deploy it on Azure and use your Azure credits for that particular deployment itself. This particular integration architecture deployment mode works very well when you have trained proprietary models, and you want to use that in your application. Now that we know a little bit about what the Azure and Fireworks integration is about, let's talk a little bit about what customers are saying about this integration itself. One, our friends at UiPath actually wanted a faster and more cost-effective model. Not only that, they actually wanted a model, an open source model, to beat the quality of a closed source Sonnet 4.6 model. And this was achievable by using models on Fireworks and Azure Foundry. And then there are stakeholders from Bolt New. What they were looking for their application was something that can scale well in terms of throughput and latency for their production use case. And this was definitely possible, and their particular, we found a solution for their particular problem using the Azure ecosystem and the Fireworks model. Lastly, some of the key decision makers at Motif were actually trying to have models run a repeatable task and also at a high volume workload. And to support that specific workload, they deployed models on Azure Foundry that was also optimized using the engine that Fireworks has, and we were able to serve that particular repeatable high volume workload itself. Now that we know a bit about what customers are telling us and what that integration is about, let's look at quick demos on this particular section itself. So when customers actually come to the Azure Foundry platform, they can go to the Discover page as pointed to in this particular video. And then in the catalog itself, go to the models page and look at the model catalogs. And within these model catalogs, if you want to find all the Fireworks models and that are optimized on Fireworks, most of them have the prefix called FW. For using the serverless pay-as-you-go method, you can just click on this particular model and then click on deploy. Once customer click on deploy, it asks you whether you want to set some custom settings. These custom settings actually are settings that you can configure based on the PTU or the rate limits that you're interested. All serverless models that are deployed through Azure and Fireworks actually have some kind of rate limit because it's shared infrastructure. So you can toggle this particular switch to figure out what kind of rate limits you want to set. And once you do and you click deploy, you will actually see a screen as shown above. And you can chat with the model. In fact, you can even use the API itself to plug into your agents or applications that you do have. You might be wondering, OK, great, I can use a model that already exists in the catalog. But what do I do if I care about my custom models itself? In this case, you can even upload your custom models. So you might have to train these models on Fireworks and download these models. But once you do, actually uploading it and deploying it is quite straightforward, and it's just a bunch of clicks. In this particular video, it actually shows you how to deploy these custom models. You go to the build section of Azure itself. And once you do and go to the model pages, instead of going to the deployments, you go to the custom model section. Over here, you have a button that says Add. This lets you add your own custom models. You can name it whatever you want and choose the base architecture. If the base architecture is not by default supported, then you can contact Azure and Fireworks, and we will help you enable it on Azure itself. And once you do have it, you've got to use this command line command line prompt that it actually gave you to upload your custom model to Azure. And once it's uploaded, it's very easy to deploy. You just click on the custom model that you have on the platform, and you click deploy. It's as simple as that. And because this is your particular deployment, you don't really have any rate limits. And you can decide how many PTUs or provision throughput you want to provision for this particular deployment itself. And very similar to what we saw before, once this model is ready, you can go to the UI and chat with the model, or use the API itself to integrate with your applications or agents. Say you have your models, either custom or existing base models on Azure ready, and you want to actually deploy these models through the Azure agents itself. How do you do that? That's a question that a lot of customers ask us, and I'll quickly show you a demo on how to plug in the Fireworks models on Foundry into the agents that you found in the Azure catalog itself. So when you go to the build page, you will see even a step to look at the agents that are existing on your Azure account. And you can name your agent whatever you want and click on deploy. Once you deploy, you can change the models that works behind this particular agent itself. It'll just take a couple of minutes to deploy. And as you can see, it lists a bunch of models that the agent can use. You can choose a Fireworks model that already exists on Foundry, or you can even choose a custom model. You can even integrate these agents with different tools. It can be web search tools. It can be tools that you define or functions that you define as well. And the agent will work really well with the tools along with the Fireworks model that you have integrated the agent with. So this is all well and good, and you might be wondering, okay, let's hear an actual customer talk about deploying their application and agents using this Fireworks and Azure Foundry itself. And for that, today here we have Nico. A quick round of applause for Nico. He'll be talking about Harvey and how they use Azure and Fireworks itself.
Thank you so much, Nico, for joining. Nico leads the applied research team at Harvey AI. Harvey AI is can you guys not hear us? Is the mic working? Okay. Better now? Okay, awesome. Yeah. Nico leads the applied research team at Harvey AI. Harvey AI is a leading native AI startup, and it is used by hundreds of leading legal firms around the globe. And 3 weeks ago, they launched the new benchmark for legal, LAB, Legal Agent Benchmark. So we're excited to talk about the benchmark. We're excited to talk about how we're working together, open weight models, closure models, and orchestrating and getting to a really good price performance for applications. Okay, awesome. You want to talk a little bit about Harvey and the benchmark itself?
Sure, happy to. And thanks for having me, incredible event. So my name is Nico Grupin. I'm the head of applied research at Harvey. Harvey is, of course, the generative AI platform for legal and professional services. We serve actually thousands of law firms across the world, and our mission is to make the work that lawyers do more efficient, higher quality, and reduce the busy work within legal. So as was kind of alluded to, 3 weeks ago we launched Legal Agent Benchmark. As agents sort of proliferate in the application layer, one of the biggest questions on the top of all of our minds are, what does it mean in terms of quality? How do I think about quality in my respective vertical or domain? That's what LAB, for short, is intended to address. So it's a benchmark to measure the performance of long horizon agents on legal tasks. So what does that mean? There's really 4 components here. The first is the agent's environment. So the agent's environment is effectively a client matter. A client matter is the term that we use to describe the universe of documents, work, intermediate work product that a lawyer uses when completing a project, right? So the agent's dropped into this environment and it's given an instruction, right? And the instruction is not a detailed list of, hey, here are all of the things you need to do. It's a partner level instruction, right? Which is, hey, here's a data room, go write me an issues list. and then you have to circle back with the complete work product. So that's the context that the agent's given. It needs to rely on both its priors for how legal work is done, as well as tools and kind of harness skills, those sort of things that has available to it. It's asked to produce real legal work product. So it's not just a chat-based kind of interface, a chat answer. The agent has to produce real Word docs, Excel spreadsheets, PowerPoints, potentially many of them, 5 to 10 of them in a single scope of a task. And then it's graded using expert rubrics, right? So each task has about 50 plus rubric criteria that specify all of the material points that are considered a good work product. So overall, we have coverage of 24 legal practice areas, over 1,200 tasks total, and I think up to 75,000 total rubric criteria. So we're really excited about this for benchmarking, to spawn a number of research directions that I think we'll talk about, and to start running open weight models and post-training over as well.
It's amazing. It's great to have industry-specific benchmarks, because then you can truly capture how the models do on industry-specific tasks. Yep. And clearly the all-pass criteria which you have is very, very strict, very high measure of is the agent truly doing the task a human would do.
Yeah.
Right? So that's amazing. We'd love to talk about the work we have been doing together on fine-tuning and using the work on GLM 5.1 and using the custom harness work on top of it. If you want to talk about that a little bit.
Yeah,
we actually published an article today morning about this, so you can check it out.
Yeah, a lot of interesting work streams going on. As I mentioned, lab is not just a benchmark. We really view it as a foundation for research into all of these areas that are important for production deployments at the application layer. So think post-training of open weight models, harness optimizations, how do you bake domain specificity into an agent harness, as well as things like skills, tool use, more cutting edge kind of frontier things like memory, et cetera. So with the Fireworks team, we're partnering on a number of research tracks, including kind of straightforward post-training like SFT with 𝗬𝗍 models. We've shown some nice improvements there in terms of lift on labs, kind of all-pass scoring criteria over the base model. But the track that I'm most excited about, which we did publish today, so go check it out, is this work on advisor agents, right? So we've effectively built a system that leverages worker agents that are driven by open weight models like GLM 5.1, and then call to advisor models that are heavier, in many cases, closed source frontier models like Opus 4.7. And it turns out that you can effectively navigate the Pareto frontier of quality and cost by leveraging these hybrid systems that effectively do inference time routing. And so that's what the plot is showing here is essentially with the closed frontier, you're getting the frontier of performance, but it often comes with significant cost and latency trade-offs. Open weight models, much cheaper, much faster, greater security guarantees, but with that trade-off in performance. And with this hybrid system, not only are we maintaining quality at a lower cost and latency, but we're actually improving it in many cases. So really excited line of work, and I think we're going to continue to build upon it.
It's awesome, yeah. Up to 2.4x cheaper on a task where it's about 30% better on the all-pass metric, which is really, really cool. I think I was talking about this earlier in the session, like a lot of the companies are using the frontier closed model for all tasks. It's like having an aircraft carrier to point at a bunker as well as to point at an ant. You don't need that. Like you have to have judgment on where and what kind of models are needed, and open models are actually really good. On that note, actually, I would love to hear Harvey's strategy around open models in general. Like, why do you think it's important for Harvey to leverage open models?
Yeah. So I think what's great about partnership like ours with Fireworks is there's kind of two sides here, right? There's the consumption of open weight models, base models, through a managed inference provider. We're interested in using these out of the box. And then there's also this question of, hey, can we improve open weight models via post-training, right? So we're investing in both parts of this equation. And with respect to post-training in particular, I think there are four kind of key considerations here that make this an extremely kind of compelling premise for us. The first, everyone thinks I'm going to say cost and latency first. That's definitely there. The first is actually domain expertise, right? So what we've seen through our evaluations is that there's a significant element of jagged intelligence, right? And so what that means is, this is a phrase coined by 𝗦𝗽𝗲𝗀𝗀𝗶𝟐. It refers to this observation that we've sort of seen in many different verticals and with language models generally, that they're really, really good at certain things, and then they fail miserably at other things. And it's really hard to interpret or reason about why that is for any given model, right? And we see the same thing in legal, right? A model might be really strong at transactional work, like corporate M&A, financial due diligence, but poor at litigation work, like case law research, writing intensive tasks, something like that, right? And so via post-training, we can kind of smoothen out these rough edges and bring the model up to speed across all practice areas, disciplines, types of work. So that's one. Cost and latency is the second factor. I think you described it perfectly, as you don't need to bring the Ferrari off of the racetrack if you don't need to. I think we see sort of a bimodal distribution of usage emerging, right? Where for really high stakes, really complex work, you'll pay a premium, use the frontier closed source models. But there's also a lot of simpler work that open weight models are perfectly well suited for. So routing between these two modes is going to become increasingly important. And then something that we think about a lot, that I think the industry as a whole is starting to come around to, is security and governance, right? So for the highest stakes type of work, what our customers are really asking us for is a secure deployment within our VPC. Open weight models enable that by also having access to things like the complete reasoning trace of the model. You can do much greater interpretability, auditability work on top of the behavior of an agent, which is increasingly becoming important for compliance reasons over time. So all that is to say, both the consumption of open weight models and post-training increasingly important for us at Harvey.
Love all the points that you put forward and the expertise and the agent work that you're talking about. If you can double click on that and speak a bit more about the end-to-end iteration cycle with Fireworks and what's possible today that was not possible previously, that would be great.
Yeah, so within the managed inference side, it's basically plug and play, which is great because you don't need to do that iteration, right? So we can start consuming open source models pretty quickly. And then with all of the work that you've done around managed training infrastructure, it makes the iteration loop much tighter, much faster, much more efficient. We have a saying at Harvey, it's that all timelines are compressed, right? In this sort of dynamic AI landscape and environment that we're in. That applies to research as well, right? So being able to pick up the pace on things like post-training experiments, running many iterations in parallel and in a pretty low-touch manner for our research team, picks up our velocity, which is kind of a crucial factor for us.
And like you said, I think at Fireworks, we too believe that all iteration cycles are compressed. Yeah. One thing I would love for you to dive a little bit deeper on is you've always been an Azure customer. Yeah. So how does this particular Foundry with Fireworks partnership really help you? And if there are customers today who are trying to use the similar platform and paths, what advice or recommendation would you have?
Yeah, absolutely. Well, I mean, this is Microsoft Foundry, right? When I think of enterprise-grade infrastructure, especially AI infrastructure, I immediately think of Microsoft Foundry, right? Like I said earlier, legal work is the highest stakes type of knowledge work. For that, you need the highest grade of infrastructure, security, governance, compliance, all of these things, right? So that's why we've been kind of a happy Azure customer for this whole time, and I think that applies to model training as well. Right, so with Fireworks, it's sort of a best of both worlds scenario where you can take this enterprise-grade infrastructure that we've already been leveraging and then layer on managed inference for open weight models, training infrastructure, and then seamless deployment of those models, right? That's not, significantly handicapping our own infrastructure teams, right? So it's a marriage of these two incredible things. We're very excited about it. And just to give a little bit of kind of historical context, when I joined Harvey, we were talking about this off stage. We were 5 or 6 people in an Airbnb, forget innovative AI problems. It was, we were thinking about whether the Wi-Fi was on in any given day. But this was 3 years ago before a lot of this AI infrastructure existed, right? And I can't tell you how relieving it is to me now and how much better I sleep at night knowing that we don't have to go figure this all out ourselves and that we can sort of ride the tailwinds of your great work and the great work of your partnership with Microsoft. So my advice would be, if you're a founder starting an AI native company today and building your AI stack for the first time, or if you're a larger enterprise and you're rebuilding your AI stack to be sort of agent native, I would ride the tailwinds that are available to you, and I would recommend using this managed infrastructure. As we said, all timelines are compressed, so it'll help you move much, much faster.
Okay, thank you so much for your time in coming here and talking about Harvey itself. And just as Nico said, if you are starting a new use case or reimagining your use case and already using Azure, then do go out and check out Fireworks models on Azure itself. You have different modes that you can deploy and integrate into your agents, whether you're using agents on Azure or agents that you built yourself as well. Thank you for your time, and happy to take any questions for Nico, Vivek, or myself as well.